Assuming that you put Betelgeuse where the Sun is, it would extend to the orbit of Jupiter. A monster, totally temperamental and likely to explode, it is among the most observable sources of radio energy in the entire universe, emitting more energy than 1 billion suns. Betelgeuse, or bug juice, is a red supergiant star. If you placed it where the Sun is, it would reach Jupiter's orbit, huge, utterly surprising, and prone to explode. When we think of stars, we likely imagine small twinkling objects in the night sky. Generally, this is how we see them from Earth. However, stars are something entirely different. In fact, one of the most recognizable stars, Betelgeuse, is far larger than our Sun. For years, this star has puzzled scientists. Recently, something much more concerning has been happening to Betelgeuse, leaving astronomers and other experts deeply worried. Join us in this exploration of the incredible news about Betelgeuse, its predicted destruction as foreseen by the James Webb Space Telescope, and what this development means for our universe and life on Earth. As explained by physicist Michio Kaku, Betelgeuse is a colossal marvel, a giant star that has fascinated astronomers for ages. A Greek astronomer named Antonius was the first to discover it. This star is so massive that it can be seen in the night sky from Earth, especially during winter. If you're into astronomy, you've probably observed or heard of this star. The reddish-orange star marks the upper left shoulder of the Orion constellation. This star is ancient and is one of the brightest in the night sky. However, something unusual about Betelgeuse's brightness is that it isn't constant, it fluctuates. This variability is one of its remarkable characteristics, but not the only one. 33 seconds. Let's examine some of Betelgeuse's unique properties. Most of the stars visible in the night sky are far from Earth. The closest star, Proxima Centauri, is 4.2 light-years away. To understand this distance, a light-year represents traveling at the speed of light, 186,000 miles per second, for an entire year. That's billions of miles. When we say the nearest star is 4.2 light-years away, it means it's billions of miles from Earth. Now, consider that some stars are much farther away. Betelgeuse is one of them, located approximately 600 light-years from Earth. Even if we could travel at the speed of light, it would take 600 years to reach it. Currently, no human-made spacecraft can move that fast. Despite its immense distance, Betelgeuse still shines brightly in our sky. You may wonder how this is possible. Its brightness is due to its unique characteristics, its massive size and tremendous luminosity. Betelgeuse is significantly larger than our Sun. Its radius is estimated to be about 700 times that of the Sun. Unfortunately, even when observed through modern telescopes, Betelgeuse appears as a disk in space, while other stars appear as tiny points of light. This is believed to result from reactions occurring in the outer layers of its atmosphere. In terms of mass, Betelgeuse weighs between 12 and 19 solar masses. A solar mass is a standard unit used by astronomers. Where one solar mass equals the mass of our Sun, scientists cannot determine Betelgeuse's exact mass because it lacks orbiting planetary bodies for comparison, and we cannot measure it directly from Earth. However, this still makes Betelgeuse significantly more massive than our Sun. Betelgeuse's brightness fluctuates between magnitudes 0 and plus 1.6. In simpler terms, it is generally far brighter than our Sun. It is no wonder it earned the nickname Red Giant. However, its brightness isn't constant. It varies due to its pulsations. When Betelgeuse expands, it becomes brighter, and when it contracts, it dims. This cycle can last from 10 to 100 days or even longer. 3 minutes and 20 seconds. A unique feature of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field in these spots is far stronger than on a typical star's surface. However, these strong magnetic fields obstruct the flow of hot gas to the star's outer layers, causing these regions to be cooler. The fact that Betelgeuse has so many of these spots compared to our Sun explains why it is cooler despite its size and brightness. The Sun also has dark magnetic spots, but those on Betelgeuse are much larger and more numerous. To give you an idea, the spots on Betelgeuse can be twice as large as Earth. Betelgeuse also boasts a magnetic field that is several times stronger than the Sun's. This field is why, when viewed through a telescope, the gases on the outer layers of Betelgeuse appear as swirls and arcs. 4 minutes and 29 seconds. Betelgeuse has a surface temperature of around 3,500 Kelvin. This low temperature contributes to its lower energy output compared to other stars and gives it its characteristic red color. However, Betelgeuse wasn't always red. About 1 million years ago, it was yellowish, similar to our Sun. Over time, its color shifted to orange-red, and around 100,000 years ago, it gradually turned into the red star we see today. This fact has led scientists to believe the star is evolving. Betelgeuse produces up to 100,000 times more energy than the Sun. If it weren't so far away, it would have been a fierce competitor to our Sun. The fact that this incredible size allows Betelgeuse to hold an enormous amount of energy. As a red supergiant, it is in the final stages of its life, nearing a spectacular supernova explosion. This has astronomers on edge. Betelgeuse, one of the most famous and well-studied stars, has been behaving in ways that suggest its end could be near. In recent years, the fluctuations in Betelgeuse's brightness have become more dramatic than ever before. In late 2019 and early 2020, the star experienced an unprecedented dimming event, losing about 60% of its brightness. This sparked a wave of scientific investigations. Some scientists attributed the dimming to a massive ejection of dust, while others speculated it could signal the star's imminent collapse. 7 minutes and 12 seconds. If Betelgeuse were to explode as a supernova, it would be a celestial event unlike anything witnessed in modern astronomy. The explosion would be visible from Earth, even during the daytime, and could shine brighter than the full moon for months. The blast would release an immense amount of energy, creating a nebula that would eventually disperse into space. Despite its colossal power, Betelgeuse is far enough from Earth that its explosion wouldn't pose a direct threat to us. The energy and radiation would mostly be absorbed by the vast expanse of space. However, astronomers are eager to observe this event to learn more about stellar evolution and the mechanics of supernovae. 8 minutes and 16 seconds. What happens after the supernova depends on Betelgeuse's exact mass. If its mass is on the lower end of estimates, around 12 solar masses, it could collapse into a neutron star, a superdense remnant left after the explosion. If it is more massive, closer to 19 solar masses, it could form a black hole, an object so dense that not even light can escape its gravitational pull. Either outcome would be a monumental event in our cosmic neighborhood. The explosion of Betelgeuse would enrich surrounding space with heavy elements, contributing to the formation of new stars and planets in the future. 9 minutes and 18 seconds. The importance of studying Betelgeuse cannot be overstated. Astronomers continue to monitor the star closely using advanced instruments like the James Webb Space Telescope and the Hubble Space Telescope. By observing its behavior, they hope to refine their understanding of how massive stars live and die. Betelgeuse serves as a rare case study, offering us a front-row seat to the life cycle of a dying supergiant. While there's no exact timeline for when Betelgeuse will explode, scientists estimate it could happen any time within the next 100,000 years, a blink of an eye in cosmic terms.